In this video, we're going to keep solving exponential equations, but instead of getting a common base, we're going to solve these exponential equations using logarithms. So, I have 10 to the x is equal to 3.91. The base right here is 10. So I'm going to take a log base 10 on both sides. So that's going to be the log of 10 to the x is equal to the log of 3.91, and on this side the log and the base 10 cancel out, so we get x is equal to the common log of 3.91. Now I have no idea what that is. I'm not really even too sure how to approximate it, but I do have a calculator handy. And I'm going to take my calculator and I'm going to input log 3.91, enter, and I'll get 0.592, let's call it. So x is approximately 0.592. So I've got my exact solution right here and then my approximate solution. I'm going to do the same thing over here with e to the x is equal to 7.4. I'm going to look and say, well, my base is e, so the base of my logarithm is going to be e as well. I'm going to take the natural log of e to the x, and that's going to be equal to the natural log of 7.4. So, again, natural log and that base of e cancel out, and what remains is x, and x is equal to the natural log of 7.4. So x is approximately natural log 7.4 2.00. And in both cases I expressed it using 1, 2, 3 significant figures. 1, 2, 3 significant figures. Okay, we're going to do some more solving with logarithms here. This problem on the left, 5 to the x minus 1 is equal to 17. I've got a base 5. I could use a logarithm base 5, but I'm actually just going to apply the natural log to this. So we'll get, let's make that green to match. The natural log of 5 to the x minus 1 is equal to the natural log of 17. So the x minus 1 is going to come out, so it'll be x minus 1 times the natural log of 5 is equal to the natural log of 17. So we're going to divide both sides by the natural log of 5. On the left hand side this is going to reduce and we'll be left with just x minus 1. On the right hand side it will be the natural log of 17 divided by the natural log of 5. I don't like how those parentheses look. I'm going to get rid of them. I'm just going to write ln 17 over ln 5. The general rule is that if you've got something complicated like 5 to the x minus 1 where there's some doubt of what is a part of the argument of the logarithm or what's outside of the logarithm, absolutely use parentheses. For just a single digit like 17, most people don't use parentheses. I tend to, but those parentheses looked too much like a 1, and it could be the natural log of 15. So if I can't tell, I can't expect someone else to read my handwriting, so I chose to erase them. From here, x minus 1 is equal to the ratio of natural log of 17 over natural log of 5. I'm going to add 1. Because of this 1 right here, we add 1 to both sides. And how do we write that? X is going to be ln 17 over ln 5, quantity added to 1. Just like that. And we're once again going to seek to get an approximate answer by taking ln 17. See, this is where the parentheses are important when you're adding it into a calculator. Plus 1. 2.76, and again I'm just going to keep 3 digits, so this is approximately 2.76. Great. And let's do that with this expression like right here. 4 times e to the 7x is equal to 10,273. First off, I don't want that, so I'm going to divide by 4. And what we'll be left with is e to the 7x is equal to 10,273 over 4. Now I'm going to take the natural log of both sides. So we're going to have the natural log of e to the 7x, which will just give me 7x, and that's going to be equal to the natural log of this number, which is just some number, and it's okay, it's some real number. It works in the domain of the logarithm because it's greater than 0, right? 17, 15, those are both greater than 0. They're in the domain of the logarithm. This is some number greater than 0. It's in the domain of this logarithm. And how do I have to write that? Natural log of that big number. I'm still going to just keep entering it as that fraction. And then I'm going to divide it by 7. And I'm going to be clever, and I'm going to write that as 1/7 natural log of this expression, which is the same as the 7th root of this fraction. But if I'm going to enter that in a calculator, I think the 7th root is too much trouble. I'm going to do 1 divided by 7 times natural log of 10273 divided by 4, close it off, and hit enter. 1.12. Yep. Again, I'm just keeping 3 digits. Well, you know what? Let's go to 4 digits. 1.122. And 4 digits on our next one would be 2.760. 4 digits. 4 digits is pretty good. 3 is pretty good. That's pretty standard if you don't have some precision that was given to you. Okay, I've got one last little question for us here, and this is a really tricky one because we have e to the 4x minus 3 e to the 2x minus 18 equals 0. And if we take a logarithm of this as is, we'd have the log of this exponential stuff, right? So we'd have ln e to the 4x minus e to the 3e to the 2x equals ln 18. And this doesn't cancel. And this doesn't work because of this negative sign here. Like so many times with other stuff, remember we're dealing with exponents, and addition and exponents just doesn't work. So we're not going to do that. Instead, what we're going to do is we're going to take and we're going to say e to the 2x, congratulations, you're now equal to u. We're going to make a u substitution. See, if I come over here and I look at e to the 4x, that's e to the 2x squared, right? 2 times 2 is 4. So this is u squared. So what I actually have here is u squared minus 3u minus 18 is equal to 0. And I think I know how to solve this because negative 18 is equal to a negative 6 times 3. Negative 6 plus 3 is equal to a negative 3. So this becomes, see here, u, we'll write this as u plus 3 times u minus 6 is equal to 0, and we'll get u is equal to negative 3, and u is equal to 6. But what was u? E to the 2x is equal to negative 3. So 2x is equal to the natural log of negative 3, which is a big, giant, nope. Negative 3 is not in the domain of the natural log. It needs to be greater than 0. Whereas over here we'll have e to the 2x is equal to 6. So 2x will be equal to the natural log of 6, which is a number. X is 1/2 of the natural log of 6. x is about, let's go 0.5 times ln 6, go 8 are we doing 4 digits? So 8959, 8959, 8959 to 4 digits. Great. And remember, we could also write that as the natural log of the square root of 6. If we had a number that we knew the square root of, that would be beneficial. Like if I had e to the 2x is equal to 25, I would say 2x is equal to the natural log of 25. So I would say x is equal to 1/2 the natural log of 25, which is the natural log of the square root of 25, which is the natural log of 5. All right. That'll do it for this video. Remember, check your domain. And I will see you next time.